Greetings everybody. This video is going over part 4 of the chapter 7 lecture notes dealing with potential energy and conservation of energy. Well, in the language of physics, potential energy, which we call PE, is stored energy, energy that you store in a system. Some common types of potential energy are there's chemical potential energy, the energy stored in a battery. As you all know, there's a chemical reaction going on inside the battery, which creates the positive and negative terminals. Well, eventually that chemical reaction dies out, and the battery dies. There's elastic potential energy, and notice I abbreviate them with the subscripts. Here's PE Chem for chemical potential energy, PE elas for elastic potential energy. That's the energy stored, for example, if you stretch a rubber band or a bungee cord. The two important ones are the ones here highlighted in the blue. We're going to study PE spring, the spring potential energy. That's the energy stored when you stretch or compress a spring, i.e. Hooke's law. And PE grav, gravitational potential energy. That's the energy stored in an object due to its height above or below some reference point. And we're going to focus on those two. And typically, if I'm talking about gravitational potential energy, because that's the most common, typically sometimes I'll drop the subscript, and I'll just call it PE, for example, here. But for all the other types of potential energy, like spring, elastic, chemical, I'll include the subscripts. But because gravitational potential energy is the most common, usually I just omit the subscript. Well, again, we'll do gravitational first, then we'll get to the spring. Well, what do we say? It's the energy stored in an object due to its height above or below some reference point. Well, and remember, potential energy, it's energy. Its MKS unit is a joule. It is a scalar. PE, gravitational potential energy, could be positive or negative, but it's simply a scalar. Well, what is gravitational potential energy? Well, it's calculated by MGH, or if you want, you could use MGY. But H or Y, they're the height of the object relative to the reference point. Now, what is the reference point? Well, we'll see it in a minute. You choose it. And by definition, with gravitational potential energy, by definition, if we say that at the reference point, the gravitational potential energy is 0. Again, an object could be at that reference point, meaning it has no potential energy. It could be above the reference point, or the object could be below the reference point. And we'll do a few examples. Basically, you choose the reference point, guided by me. You want to choose, and again, it's the point that you designate. You're saying, hey, the PE equals 0 at this point. And typically, you choose it to make the math as easy as possible. And for, probably 99 times out of 100, the reference point is going to be the lowest point or the lowest height of the object, like the floor or the ground. It could be a skier sliding down a slope. The bottom of the slope is the reference point. An object is dropped from a certain height. Maybe you release a rubber ball from a certain height and it hits the floor. We choose the floor as the reference point. But again, gravitational potential energy can be positive or negative. Any object that is below the reference point will have a negative potential energy. And again, you choose it, and basically you want to choose it such that the math comes out as easy as possible. But it doesn't matter. It's simply a mathematical tool. Physically, you're not changing the problem. You're just designating the reference point, the point at which the gravitational potential energy is 0. All right, well, let's look at an example. You have a trophy, and again, what is PE? PE is MGH, where H, by definition, that's the height relative to the reference point. Could be above or below. H can be positive if it's above the reference point, or negative if it's below. But PE is mgh. M is the mass in kilograms. G is gravity, 9.80 meters per second squared. H is in meters, and it's if the object is above the reference point, the PE is positive, meaning H is positive. If the object's below the reference point, H is negative, meaning the PE is negative. Well, let's look at this example. So you have a trophy being shown off by this careless athlete. And it's the trophy, whose mass we know, slips from the athlete's hands and drops on his foot. And assume that the athlete's hands are 1.4 meters above his foot when he drops the trophy. And when the trophy has fallen half that distance to his foot, I want to know what is the PE of the trophy. And we're calculating it twice. One, using his foot as the reference point, i.e. the lowest point, or the lowest height. 99 times out of 100, your reference point is going to be the lowest height of the object. In other words, it starts off at a height of 1.4 meters, and then it lands on his foot. So his foot, i.e. that's where the PE is 0. So that's part A. And part B, using the hands as the reference point. Okay, so part A, we know the trophy is above the reference point, so H is positive. Remember, because we're using, in part A, we're using his foot as the reference point, meaning at his foot, the PE is 0. And so initially, the trophy is above the reference point because he's holding it at some height H above his foot. So H is positive, means PE is positive. PE is mgh. Units are all good. M is 2 kilograms. G is 9.80 meters per second squared. Now remember, we're calculating the potential at half the distance to his foot. So H is 0.7 meters because it starts off at 1.4 meters. So you get 14 joules. Now what if we use his hands as the reference point? So relative to that reference point, what is the PE of the trophy when it is fallen half the distance? Now again, when the object is fallen half the distance, it is now below the reference point. Because now we're using his hands as the reference point. So it starts off at the reference point. The PE is 0 initially. Then as it falls, it is now ending up below the reference point. So when it's halfway down, when it's halfway below, the PE is going to be negative because H is negative. So here's the minus, because the height is minus 0.7 meters, because it's negative because it's below the reference point. How far below the reference point? 0.7 meters. So negative because it's below. How far below? Well, half the distance, 0.7 meters. So you get minus 14 joules, obviously. So again, you're not physically changing the problem. You want to know what is the PE when the trophy is fallen halfway. Now, depending upon your positive and negative, that depends on your reference point. And again, 99 times out of 100, the lowest height of the object. In other words, if it goes from his hands, which are 1.4 meters above his foot, down to his foot where it lands on his foot, choose the foot as the reference point. 99 times out of 100, that makes your lives very easy. Now let's finish up. What about PE spring? The energy stored when you stretch or compress a spring. Well, actually, let me save this video and do PE spring in a separate video. But again, that's, if you can understand what we mean by the reference point, that's really all you need to get from gravitational potential energy. It's just PE is mgh, where h is the height of the object relative to the reference point. You know, part A, in this example, part A, we chose the foot as the reference point, meaning the object starts off above the reference point at his hands, and then when it's halfway down, it's still above the reference point. How far above? 0.7 meters, so it's positive. And then in part B, we chose the hands as the reference point, so as the trophy falls, the height is negative because it ends up below the reference point. So that's where the negative comes into play. How far below? Well, halfway, 0.7 meters. So the only difference in the two answers is obviously A is positive, B is negative. All right, let's do the spring potential energy in the second video.